Happy holidays. I'm John Brewer, the Chief Artificial Intelligence Officer at Haystack ID, wishing you a pleasant end to 2023. 2023 was the year that generative AI really exploded into the scene in our society. It's an achievement worth celebrating. For the first time, the average users could ask a question in plain English to a computer by typing it in, and the computer would respond in plain English. And it would do so with questions that the programmers never could have envisioned being asked. The experience for the user truly felt like artificial intelligence in a way that I don't think any previous technology has. It's worth remembering that generative AI, as we've experienced it in the last 13 months, really is a difference in kind for users. One thing that I wanted to go over was to explain how generative AI is being used across our industry, so that you have the context to understand what's coming down the road. I won't name any particular eDiscovery or legal products, but I'll equip you with the language you need to ask your vendors about what they're using and how they're using it. I'm going to assume that my audience here is vaguely familiar with what ChatGPT is. If you're not, I recommend you go and check it out. It'll probably blow your mind. Also for today, I'm going to focus on large language models. Image-based generative AI systems like Stable Diffusion and Midjourney are doing remarkable things and are leading the way in a number of places, but we'll talk about them later. So how are LLMs being adapted for use in eDiscovery? Well, first let's talk about how LLMs work and how software developers interact with them. Essentially, when a product is using an LLM, they'll interact with it the same way you might as a starting ChatGPT user. They'll give it a bunch of text, then they'll get a response back. The text gets ingested as a set of tokens, which are essentially just parts of text. Without getting too deep into the weeds, a token is about 1 digit or about 3 letters. Some developers run their own models, which is to say that they own the computers, either physically or in the cloud, that run the LLM. And some use a service from companies like OpenAI or Google. Regardless of how they access the LLM, they interact with it in the same way. They give the LLM input, commonly called a prompt, and they get an output, commonly called a response. Not all models are created equal. Besides having different information that they've been trained on, so-called model knowledge, they have different costs associated with how they work. The most important property for our purposes, though, is what's called the context window. The context window is how many tokens of information the model can keep in its virtual head. Essentially, how far back it can remember. If a model only has a 4,000 token context window, it can only remember about 4 pages of text, and so by the time it makes it to the bottom of the 5th page, it's forgotten what happened at the beginning. It's important to realize that this applies to the output too, so if you've given 4 pages of text and it's given you a full page of output, as soon as it starts outputting, it will start forgetting what's at the top of the first page. Now, if you're a casual user of ChatGPT, you might not really worry about this. After all, your prompts are only a sentence or two, and your responses are at most a few paragraphs. Well, now we need to talk about how we process documents. There are a few ways to work with documents with an LLM. The most common right now is something called RAG, or Retrieval Augmented Generation. Now, quick sidebar here. RAG is a term that has only cropped up in the last few months. Some people will say that what I'm describing here is RAG. Some people will say that it isn't. I just want to get you familiar with the terminology, but the actual meaning of this term hasn't really settled yet. The general idea with RAG is that LLMs are less prone to the foibles of hallucination and fabrication when they've been given exactly the information that they're supposed to work with, and are either formatting it for human consumption or are answering questions about it. So let's start out with everybody's favorite eDiscovery question about a document. Is this document responsive? RAG says we need to build a prompt that tells the model everything it needs to know that isn't general knowledge. So we start out with an explanation of the role we're asking the model to play. You are an expert eDiscovery reviewer, attempting to determine if this document is responsive, given the rubric below. Please reply with either the word responsive or non-responsive, and give an explanation for your answer. Then we give the model some contextual information about the world and the case. For instance, knowing the current date and time comes up often, as does briefing on the plaintiff's name, defendant's name, and other pieces of information to put what the LLM is reading into context. Next, we give the model a protocol rubric for the document. This will usually be similar to what you would give a team of human reviewers who were going through these documents who might not be familiar with the details of the case. Finally, we give the text of the document itself. We let the LLM evaluate the document. Now you can see there's a lot of information here. If the context window was smaller than that whole set of instructions, plus the document, plus the response from the LLM, then we'd have a problem. RAG only works in this context because we now have models that are available that have context windows in the low hundreds of thousands of tokens, or around 200 pages of text. That's going to be long enough to accommodate most documents that we encounter, and if we do have longer documents, then we might be able to break them up if the responsiveness criteria isn't too crazy. Now, we can use RAG for anything a document review might entail. It can be used for responsiveness, it can be used for evaluating privilege, for applying tags to a document, and many other things. It does have limitations due to the context window size, however. So what other options are there? The second option for loading data into an LLM is something called fine-tuning. This is when we actually create a new large language model by starting with a base model, like GPT-4 or Llama or Palm, and add new information to it. In early 2023, this was a very popular approach to dealing with large document sets. With fine-tuning, we don't necessarily have to pass the document we're asking about. We don't even need to ask about a specific document at all. We can ask about a custodian and get answers back that span across a number of documents. That sounds amazing. The challenge with fine-tuning is that information rather gets mixed together in the LLM's model, and it can start having issues distinguishing between the truth of different types of information. A classic issue with models fine-tuned on complaints is that they will often take their statements of claims as fact and return information accordingly. Also, fine-tuning models can be very expensive, both computationally and monetarily. Fine-tuning a model often costs hundreds to thousands of dollars per gigabyte, and custom models often carry additional costs for storing and operating them. We'll get into cost comparisons later. Finally, we have a hybrid scenario. This isn't saying we're mixing RAG and fine-tuning together, although that is possible. Rather, we're mixing generative AI with more traditional AI capabilities. For other AI tools we've used, such as auto-tagging, sensitive information extraction, or technology-assisted review, we have had to have humans give the AI examples of what should or shouldn't be labeled in a particular way, and then the AI learns from the human example and goes off and does tens or hundreds of thousands of documents all by itself in a matter of minutes or hours. The idea here is that if the generative AI is expensive to run, let's have it train the older, faster models and get the best of both worlds. So that's how we do things. How do the economics fall out? Let's start with RAG. Vendors using pure RAG are usually using the larger context window models, such as GPT-4 Turbo or Claude 2, both of which have context windows over 100,000 tokens. The instructions are usually around 1,000 tokens, the context is often around 2,000 tokens, and the protocol can be as much as 4,000 tokens. The documents themselves will be around 1,000 tokens per page, so if we process a single email, we'll end up spending around 8,000 tokens of input, or around 8 cents on these larger models. The Enron dataset contains 517,000 individual emails, which would incur a cost of $41,360 or so, plus a little bit for longer emails. Now, depending on who you are and the case that you're working on, $40,000 to review 500,000 emails could be a bargain at twice the price, or it could be a show-stopping cost that is more than the budget for the entire matter. Now, that's assuming that you only need to run one prompt across the files and that you have that prompt ready to go from the word go. In practice, a custom protocol in context, at the very least, would need to be written for the case, and it's likely that they need to be tested across a set of hundreds or thousands of documents to make sure that they're right before pulling the trigger on the whole set. Now, 100 documents is only $8 a throw under this model, so the development cost is likely to be in the human time spent, but if there does turn out to be a problem in the prompt that you don't catch ahead of time, you could end up wasting $40,000 on the exercise. Now, in our example above, we are only processing 10,000 tokens, so we don't need to be using these premium 100,000 plus context window models. If we use RAG on a smaller model and restrict ourselves to only documents that fit in the context window, can we do better? If we restrict ourselves to 16 or 32,000 token models, we can end up spending less than a cent per document using something like Palm 2, dropping our total review size down to about $4,000. I think Claude Instant has a similar price point, as will older OpenAI models like GPT-3.5 Turbo. Now, these models might not be as accurate in assessing tagging or responsiveness as their more expensive counterparts are, but many sins can be forgiven for a solution that's a tenth of the price. Now, what if we tried fine-tuning the model? Well, the Enron dataset has something like 367.5 million tokens. Training that many tokens on Llama 2's 13 billion parameter model would run around $550. The 70 billion or OpenAI's GPT-3.5 Turbo would cost around $3,000. So those numbers are on par with a single RAG run. So why wouldn't we just fine-tune the model and call it a day? Well, to understand that, we need to talk about citation. Large language models aren't search engines, even if they sometimes appear to work that way. The large language model can tell you what it thinks the answer to a question is, but it usually can't tell you why. It can't cite its source. The citation problem is something that has seen a lot of work in the last year, but right now the state-of-the-art solutions are using a process called back searching. Essentially, the LLM spits out a quote of something, and then a secondary process goes back to the source documents and checks to see if that quote actually exists in any document, and then cites it if it does. If the quote can't be found, it actually chucks the result that came out of the LLM and tries again. Now, this works in a lot of circumstances. Where it doesn't work, however, is when you have a quote that appears in a large number of documents. A classic example in the legal space is contracts. Often you'll have a lot of boilerplate in a given contract, and when trying to find the source of a quote in the documents, the system might turn up an entirely different contract with the same clause. But the citation is nonsensical. Similar issues crop up across all other kinds of documents, such as disclaimers, email signatures, invoices, government forms, and other places. Secondly, even modern LLMs have a difficult time admitting that they don't know something, rather than just making up an answer, let alone past generation models that most fine-tuning is done on these days. Hallucination and inaccurate information abounds if the LLM doesn't have the information to answer a question, as the system just tries to fill in the blanks as best it can. So, while fine-tuning can be a less expensive solution and opens doors to asking questions across documents, it has its own shortcomings as well. So, what about our hybrid approach? Well, for auto-tagging or technology-assisted review, the usual implementation for the technology is using machine learning techniques. Now, how exactly those work isn't important for the moment, but essentially you have humans label a few hundred or a few thousand documents, and then the machine looks at those documents and tries to create a formula for determining whether a document should have that label or not, which is then run across the rest of the set. For something like tagging, it's usually a best effort system, while for something like technology-assisted review, you have certain statistical benchmarks that you need to hit, and if you don't reach them, you do additional training until you get an acceptable result. So the hybrid technique here would be to use the LLM to label a few hundred or a few thousand documents, and then use those labels to train the machine learning systems that can then rip through hundreds or thousands or millions of documents in a fraction of the time. In an ideal case, it's the best of both worlds. The expensive GAI is used just enough to bootstrap up the more traditional AI, and the whole project is completed in a few hours for a few $100s. In practice, though, we have alignment issues as we proceed. So, the alignment problem is a core problem in AI research. It deserves a whole video on its own, but for our purposes, what you need to know is that every time a system, be it a human or an AI, tries to teach another system what it should do, by example, some information will be lost, and the new system will be trying to do something slightly different than what it was being asked to do. The practical upshot is that in our case, the machine learning model the GAI trains will necessarily be a simpler model than the GAI itself, and may well be meaningfully less accurate. That said, we already have this problem with humans teaching the machine learning models, and indeed humans teaching other humans. If the misalignment is minimal and the cost of the GAI remains high, we may see hybrid models become the dominant force in many eDiscovery AI tasks. Generative AI is still a relatively nascent technology, and there are big questions yet to be answered regarding what it can do well, what it can do economically, and when it can do both at the same time. 2024 is going to see a lot of tools either upgrade to use GAI or come to the market new with GAI capabilities. Hopefully now you'll be able to ask about those GAI capabilities and understand more about how those tools work so you can leverage their strengths and minimize their weaknesses in your work. Almost all businesses are going to have to choose whether and how to use GAI in the near future. Choosing not to use it because it doesn't do what you want or introduces intolerable risks may well be the best choice. Ignoring it because of a vague sense that it has no use is a mistake, though. You owe it to your clients and to your organizations to review the capabilities out there and make an active choice about how you're going to handle the generative AI generation. Thank you for spending your time with me today. I hope you and yours have a safe, peaceful, and prosperous 2024. I've been John Brewer.